Recording in progress.
There's that feedback. Is there an answer wrong? All right. Okay. Yeah, I've been with the Rutgers Extension for about 40 years now, and I enjoy speaking to a lot of different groups. I was speaking at a commercial group yesterday, and probably the groups I enjoy with most, and we have a good number of commercial groups today. But I really enjoyed listening to the last regard for the certified artists. Feedback, and I like the interaction. So don't hesitate to. We do have up till 12, and so we have a lot of time. And I think we can't even cover what I hope to. I have a lot of slides there. As time has gone by, I'm getting later in my career. I start telling more stories, and I don't get as far as I used to. I used to get through the slides really quick. And I no longer provide a flash show. And all right, so yeah, this is going to be a talk. And by the way, what I do at Rutgers is I do my regular responsibilities. I do consulting work with.
Why it's not easy.
It is Mary. There's somebody online that's not muted.
Yes.
So if you can hear me, please mute yourself. If we get your feedback. Maybe not be bothered. All right, so that's the problem. They're not muting themselves. We've been doing this now for 3 years. This is never ending. So yeah, what I do is a consulting service with yeah, I look for the second I work with usually about 15 greenhouses and nurseries every year. So the past 20 years. So this is going to be a talk on the primary key insect or mite species that we find in our landscapes, in our urban landscapes, residential, commercial landscapes, trees and shrubs. And so we've got one handout that I'm not going to really refer to. It's kind of a top 100. I've already mentioned it to many of you already. And this is just a listing. And if you look at that handout, you notice it's divided into categories. Those insects and mites that have sucking mouth, those insects that have teeth, those are gall. Not that many of them, there's only a couple of them that are kind of serious pests, and I'll kind of mention them early on. And so I have them up to about 100. I do add new ones occasionally, and I'll subtract some that kind of disappear. But there are some insect pests that when I first started working in the industry in the early 80s, there's pests that we used to deal with that pretty much under the radar, or we don't even see them anymore. And so they kind of come, new ones come in. The last 10 years in New Jersey, last decade, we've had a lot of new exotic introductions of both insects and diseases. And there's a new one that those of you are not aware of this, commercial people are, the oak wilt coming in, and that's right on our doorstep. So 2 different corners. It's in the Philadelphia area and also in the metropolitan area of New York and Long Island. The oak wilt disease is pretty devastating to red oaks, and red oaks are state free. Just to remind someone who is on listening, but mute yourself, or mute your computer, if you will. Or maybe there's not. The echo is really bad. Okay, thanks. So I think we could get started, huh? And, right, and the answer's not working. What? Awfully good start, huh? Wow. No, it's not too fancy at all. And I bring my own laptop, and I should always use that, because I know that works. And I'm not familiar with this, so Mary is not advancing. I can't even do a manual. Yeah. It's not an Apple, is it?
No, they work for.
Yeah, I work. I probably won't get to all of them there, but if we go along, I really do encourage. Any kind of questions or just want to inject something like good experience, that always improves the presentation. Yeah, I'm gonna talk about that. I just want to know your opinion. Yeah. Well, the spotted lanternfly, I assume everyone has seen it, right? Yeah, it first came into New Jersey, I think it was 2018. Was it what's going to be now? Well, came from China. Yeah, we'll do what we guess. That was China.
So what I heard is true.
Globalism. Yeah, it's true. And other parts of Asia as well. So it's native from Eastern Asia. And the spotted lanternfly. Well, I'll get to it. I think actually my first few slides, we'll get to that. And
Sounds good.
well, you asked a question, and I think it's right now at the moment. The spotted lanternfly, one that's now established in every single county in New Jersey. And it's in probably at least, I always keep losing track. I think it's in 15 states. Maybe I'm wrong. Maybe it's they are, the spotted lanternfly, you know, that the hind wings of the spotted lanternfly is a scarlet color. I think it's kind of reflectors. Right. So there it is. Good. Three question answer. It's a flat plant marker. It does have piercing sucking parts, and it feeds in the sap of the tree. And the young instars, which are the immature stages, doesn't have a complete metamorphosis. It has what's called an incomplete metamorphosis. So it doesn't have a pupation stage to it. But there's 4 instars or immature stages. And they are, the first 3 instars are feeding on leaves. Because their mouth parts are not quite sturdy enough to be able to penetrate woody tissue. So they have to feed on the leaves first. And then
Steve, is your microphone on?
I thought I had it on, but let me try it again here. There's no light that indicates it. Keep pressing it. So, I
UHF is connected.
All right. We're getting that. Okay. All right. And so there's the adult. I took this photograph
It's a 2018 because it actually had just arrived in New Jersey that particular fall. It was discovered in 3 different counties, just came in Berks County, where it was first discovered in 2014. And Berks County is where I have 3 or 4 relatives live there. A tree of heaven in their properties, kind of wild trees in the back corner of their lots, and they all had the infestations. And I got loads of pictures even before the insect got to New Jersey. So yeah, I had to always be careful when I drove back to New Jersey that some of them didn't fly into my car, and I was transferring them. But I took this one in 2018, but they had been. That's about when they arrived in New Jersey. And there's an egg mass, and so right now they are in the egg stage. You can see that. I think the light okay here, I guess. Is there a chance the lights can be dimmed a bit, or is this either on or off? We're in a new room, so everything's kind of novel here. Yeah, that's probably a little better, right? Okay. That's the mass, and they're only about a little more than maybe an inch in size. Each mass, female have anywhere between typically 30 to 50 eggs. And they're kind of interesting is how they lay them in like a string, usually 6 or 7 in a single row, and maybe 6 or 7 rows, next to each other. And this was taken in April, which is kind of toward the end of the, it's getting ready to hatch, because they will hatch in sometime in May. They had gone through the winter, and as winter, this egg mass, which has been covered with a protein protective, like almost like mud. The female will cover her eggs when she lays them. And at first, it's very smooth. I have pictures showing you how smooth they are, but as in the freeze and the thawing and just general weathering, they start to crack and open up, and you can see some of the exposed eggs now. And now it's been shown that one of the additional controls that can be done is the use of oils. If you get good coverage, especially if they've weathered, you can cover them with oils, and it'll prevent the eggs from hatching. And so that's another control that can be utilized. But here when they hatch, and it's going to be sometime typically in May when they'll be hatching, middle of the May. You see we're down in Gloucester County, and so, yeah, they definitely will probably hatch maybe toward the second week of start seeing it. And the first will have the same coloration, jet black coloration with the white spots on them. You can see how they're really quite small, and but there's tremendous numbers. And I mentioned the one egg mass has 30 to 50 eggs, but when they spot a lanternfly, they'll select maybe just a few trees, really concentrate the eggs. You can put hundreds of eggs on a tree. And the trouble is that sometimes if it's a big tree, the vast majority, 90% above. So they're not something that you can easily. And it's not, if you have a few, you can scrape them off, plastic bag, and just take them because they'll probably crawl right up again. But so that's the first instar, and that's going to be in May. And then they're only about 1/8 of an inch, so they're quite small, 1/8 of an inch. So some people may and so then they move to that second instar. They more than double in size to 3/16 of an inch, or rather. There's a close up of them. And here are some of the egg masses where they come from, but they came them. These eggs are all been hatched, and these young instars, they are remarkably mobile. They move because you feed on the weeds, and oftentimes they'll not even stay on a particular tree where the eggs they'll move elsewhere. And they'll maybe sometimes what they want to feed on, they'll back up the tree again. But these young stages, they cannot feed on the bark. They can only feed on the leaves, or perhaps on the stems. So that's where they can feed as well. So that's probably was be about early June when I.
As it was in the beginning, is now, never
And
shall
what they
be.
also do, even in these early stages, they are sucking sap within the phloem,
Jesus, forgive us
where the
our sins,
photosynthase
save us from the
tissue,
needles, souls,
parts of the plants, the leaves, and the
especially
roots and so
those most needed.
and so they have to suck up a lot of it to get the necessary protein that they need later on, especially if their females going to be laying waxy cover for them. Requires a lot of and sap is not protein rich, and so they have to suck up a lot of the sap. And there's plenty of carbohydrates and sugars that they get from it. So that's a quick energy, but not protein. So to get the sufficient protein, they do suck up a tremendous amount, and then they get rid of all the stuff they don't need. And they just exude it out. That's called honeydew. Maybe familiar with aphids or some soft scales. Mealybugs produce honeydew, and white flies produce honeydew. And that's because they're feeding in the phloem. And so you can see these shiny, sticky parts of these leaves. That's where the honeydew, well, it's very shiny and sticky initially, but then you get a black sooty mold fungus. It's not a pathogenic, it's not going to infect the trees, but it does cover them up and covered and it prevents photosynthesis. And it can kill, the leaves or the branches, and some, if it's a small tree, they can potentially kill the entire tree if the is covered over. And so and that's just some of the black sooty mold. And then they move from that third instar, which is the last stage where they have that black and white coloration, to a strikingly different, a reddish white and a black coloration that's shown there. And they increase their size significantly up to maybe a ½ inch or possibly even a bit more than that. And so they each time they increase their size about 50%. Stage, immature stage, before they become the adult. But this fourth instar stage with this red coloration, they can now start to feed in the bark. Has become stout enough and strong enough to be able to penetrate the bark and then start sucking sap from those tissues instead of the leaves. So they don't leave. Adult stage is going to be probably, you'll start seeing adults the end of July, and this one was taken in August. They have a long life cycle, just one generation. So they can hatch in May, and especially if it's kind of on the late side of hatching, they can be adults all the way to late November. And I've heard reports you can even see them in early December if it hasn't gotten too cold yet for the upcoming winter. And then that's many months they live. For insect, that's for most species. And I can't probably see it, but you may see this red coloration. I don't know if this pointer works. The eyes are black. A pair of eyes, and that red coloration are not the eyes. Some people think that's the eye. That's just a sensory organ. It's used to sense volatiles and maybe to help find trees they want to feed on, and put those reddish sensory organs for. And that's just kind of a dark picture, but and starting around September, they have this migration period, and that become a real nuisance to people. Maybe you didn't really notice the young instar because they can't fly, but then they become adults, and then the month of August, they kind of don't move quite so much. But when it comes, maybe around Labor Day or even possibly a little bit before, and then for maybe a good 3 weeks or longer, I would say the entire month of September, they have this migration period where they're flying all over the place. And that's when they really become a nuisance and people notice them and they start flying into you. And, they're kind of clumsy flyers. They're a big insect. They're about 1 inch in size. And when they fly, you can see
they're kind of like an aircraft carrier, rather a big jumbo jet trying to land on an aircraft carrier. They don't really have good turning abilities. And so if they hit you, they don't really mean to do that. They're not aiming for you, but they just can't move out of the way fast enough. So they're really better hoppers because they're not plane hoppers. They're better hoppers than flyers. However, they can get themselves up in the air, and they are excellent gliders. They can glide and go for far distances if the wind will carry them that way. So they are able to move for good distances and maybe sometimes a few miles as an adult. Okay. And some of these slides are a little bit dark shown here. And so this, we can kind of move through here. They feed on quite a few different hosts. Their favorite hosts that you'll see in the landscape, certainly tree of heaven. If you're all familiar with the tree of heaven, that's probably the one tree species that they will try to find. That's their preference. But if they can't, they will find other trees that are suitable. And they don't require the tree of heaven to complete their life cycle. They can feed on red maples. They really seem to gravitate toward the red maples. They like birch trees, river birch, gray birch, like willows. They like some of the sumacs. They'll feed on black walnut. They'll feed on. And so actually one of the things about black walnut and the sumacs, they kind of mimic the appearance of tree of heaven. They each have these pinnately compound leaves, and a long leaf. A tree of heaven can have one leaf that's 3 feet long. And they have multiple leaflets that are called pinnately, lined up each other all the way down to the length. It's called a rachis of the leaf, and it could be 3 feet long. Black walnuts and sumacs usually don't have a leaf quite that long, but they're similarly compound. So people confuse those species quite readily. All right. And this is showing you that red coloration. They're not that difficult to kill. And if you use a type of like a nerve poison to kill them with, they lose control of their muscles, and their wings start opening up, and they expose the hind wing with that red coloration. And so when they're dying, you'll start often see them exposing that bright red coloration, and you know that they've lost control of their wings, and that's the nerve poison. It's doing that. Okay. All right. So here's that egg mass I was talking about. What's curious, for maybe less than 12 hours or so, when they first lay an egg mass, it's white. It's a polar white color. And I remember when I saw this, and I took the photograph here in Pennsylvania in October of 19, I hadn't been educated enough about that white coloration, which lasts for about 12 hours or even less before they turn to the more gray color, which camouflages nicely with the bark, with any bark species. So that the white coloration fades in a hurry. But I saw this, and in fact, I didn't even see the gray older egg mass. It was camouflaged. So I was just kind of startled by this white. What is that? Not realizing it was just a very young spotted lanternfly egg mass. And so, but it doesn't stay that color very long. Just a matter of 12 hours, from what I've been told, it changes colors to that gray. All right. And I actually made a mistake here. I said freshly laid versus a few weeks old. This egg mass here could be only a day old. It's already made that change. So, and we all learn as we go through this. You pick up information. This is a new insect. We only first even recognized it in Pennsylvania in 2014, and most people had no idea what it was, and they had to consult the entomologist to figure out what was going on. And so, yeah, some of these, it's this room and the windows there, it makes things really bright, but that's what happens sometimes when the female, when she lays her eggs. You can see how they lined up nicely in these rows of strings of beads. Every once in a while, I don't even know quite what the percentage is, but it seems like it's at least 5% of the time. I'm just guessing there. But that waxy mud-like protein coat is not. And kind of what's going on there, why, and I assume maybe they have the ability to usually lay 2 egg masses, each female, during her life cycle. And if she can attempt to make a 3rd egg mass, and perhaps when they attempt that 3rd egg mass, and I'm kind of speculating here because I've not seen this written in the literature, but they may not have taken up enough protein to put that waxy cover over the eggs. They have enough to make the eggs themselves, but now they're naked or they're exposed, as shown there. And so whether this creates a little bit less viability because they're exposed to the weather, yes, it probably does reduce the successful percent hatch rate. So, all right. I'm sure have some of you seen these, what we call the naked egg masses. Some of you seen these? Yeah. So I'm going it really quickly again. That's the 3rd instar, the last stage before they become the 4th with that red color. And that's the 1/2 inch long, 5/8 of it. They get pretty good size, that 4th instar right before, and you can't really see it, but these are pads that are starting to develop, which indicates that the next developmental stage will be the adult stage. Then they'll have the wings and they can fly. Okay. And a male at the top and the female in the middle, and then the 4th instar there at the bottom. And so that's all has that red coloration to it. Okay. Yes, someone had mentioned it's a beautiful insect, but it's a nuisance. Yes.
In the 3rd and 4th stage.
Right.
In your agent also farm the nymphs?
Yes. Yeah. Most of our traditional, organophosphates or carbamates or pyrethroids, they do an excellent job of killing these. It's not difficult to kill them as long as you make good contact and coverage. One that was used a lot and now is being removed for use. In fact, homeowners can no longer purchase and apply themselves the neonicotinoids, which are systemics. They are, maybe you've heard of Merit or Advanced Garden Formula. Available to buy anymore. As a commercial license applicator, you can continue to use these neonicotinoids, and there's about a 6 of them. There's things like Flagship and TriStar and Arena, and there's a number of different ones. They all have similar modes of action. Safari is one that has extremely water soluble. That was they call it Teflon. That's the active ingredient. But the commercial applicators can continue to use them at residential landscapes until I guess October of this year, and then it's no longer available legally. Now, if you're an agriculture-based operation like greenhouses or nurseries or farmers, you can continue to use the neonicotinoids into the next years ahead until eventually maybe they are eliminated. The problem with the neonicotinoids is the concerns they have potentially with pollinators. Yeah, that's the concern. There's most European countries have banned the use of these. And so, yeah, it can have a negative effect on pollinators, but it's unfortunate because this was a very useful material, neonicotinoids, and I've used them myself on my tree of, I have 3 60-foot green ash trees on my property, and I've been protecting them against the emerald ash borer with using a neonicotinoid. And so I have a pesticide license, so I'm legally able to do it for 1 more year this year. And then after that, I won't be able to use it, but hopefully the emerald ash won't be high pressure. All the trees in my area have all been killed. I'm the only 3 left. It's a 110-acre townhouse condominium complex. There was about 105 green ash trees I counted back around 2015. All of them are now dead, and most have been removed. And there's 3 trees left, and that's the only I've treated them. It works. You can save your trees. It's a really done. So, yes.
On that note, what do you recommend? Is it them and try to protect them.
Now I kind of got off topic, talk about spot. Yeah. Yes, well, right now, I probably would say, I mean, there are some reduced risk materials that can work. Neem oil has been applied. Okay, now that's not a real dynamic material. Oftentimes I have greenhouse growers who use neem oil, which is azadirachtin is the active ingredient. It's something that's been used, it's from the neem tree. It's the seed pod. It's the oil in the seed pods that is the active ingredient in neem. And it's been used in places like India for toothpaste, for cleaning their teeth. So its risk is low. It's a low risk material, but it's, as far as dynamic, it's not gonna make the insects hit the ground screaming. I mean, they're gonna maybe have some impact on it. It'll be something you'll have to apply multiple times. And that's one way to control them.
Some of their poisons
It's worked really well. I mean, the pyrethroids, which are available for homeowners, you can buy them, you know, Lowe's or Home Depot or any garden center will have these pyrethroids, them that are available under different trade names. And then there's Sevin, probably most of you have heard of Sevin, which is carbaryl. That works really well. That gives you on bark about a 10-day residual. So if they climb up, because they like to climb trees, these both adult stage and immature stages, they'll climb up and down the trees constantly. And so the Sevin will give you 10-day results. You have to reapply every 10 days. But so that's another material. And there is a number of different non-chemical controls. I didn't plan on really doing this, but I should have, especially for certified gardeners. If maybe some of you have heard of the circle traps. Well, initially they were recommending the sticky traps to put around the trunks of the trees, but they got kind of messy, you know, and you had to maybe replace them periodically if they got too gunked up with everything. And you get things you don't want to catch that are being put on those. You know, birds have been caught on these sticky bands. You wrap around the trunks of the trees, maybe about a foot in diameter or so, or height. And then things, you know, beneficial insects and even small mammals have been caught on these things. And then they recommend putting a cage around it to prevent that from happening. But these circle traps, has anyone ever attempted to use circle traps? Are you familiar with circle traps? It's really a simplistic thing, but it's ingenious. It's you behave against these spotted lanternflies. That they have this tendency to always want to climb up and down trees. Is you put this, it's like a funnel. It's almost I would call it a funnel shape. And at the top of this funnel is a plastic bag that you just hang from the smaller opening, maybe about 2.5 to 3 inches in the opening. And the plastic bag hangs down. And as the both adults, young instars, they'll climb up the trees and they'll go inside this funnel, increasingly getting smaller and smaller. And they go through the opening and they fall down into the plastic bag. And but they don't even need a pheromone for this. They just use this behavior against them. And they, for some strange reason, they're not able to climb back out. I mean, the opening is still there, but they don't climb back out. And it's just a strange thing, that behavior of this insect don't allow them to do this. And maybe you catch a lot of them that way, and maybe every 2 weeks or 3 weeks you have to empty and dispose of them. But it's been shown that, I don't know what the percentage of catch is, but sometimes significant. You know, make them yourself. I don't know who sells them. I know we were on the county, and I'm sure Mary has examples. Yeah. Mary, do you have examples that maybe the Department of Agriculture or DEP have sent you these circle traps for the spotted lanternflies? Well, they sent them to Monmouth County.
Really?
Yeah. Oh,
I'll
okay.
have to look into it.
Yeah. Yeah. So, have you familiar with the circle traps yourself? Have you
No.
seen them? Okay. Well, it's something that I think Renters Associate master gardeners are familiar with, and they've been most of the counties with those programs have been given these circle traps. But yeah, I have to look into that. I'm not sure. All right. Okay, you can see about an inch in size is what the adults are, full-size adult. That's a female. Female is always going to be a little bit larger than males. That's true in the insect world. Females are always going to be slightly larger than males, and that's the trend. Okay, and there, if you can see this in the back, maybe not. You can see the life cycle and eggs hatching, or rather egg masses are laid in September. Well, the egg mass present on the tree from September all the way into June before they maybe all have hatched. And then they hatch in mid-May to June. And then there's the second, third, and fourth instars. And so it's a long life cycle for one generation. All right. All right. So yeah, this isn't coming up too clear. It's a little bit too bright in here, but you can still see that. But these are some of the hosts they like to feed on. I've already mentioned the tree of heaven. Number one, black maples, red maples in particular, sycamore, birch, magnolia, willows, tulip trees, zelkova, lilac, styrac. Styrac is Japanese silver bell. Those who are familiar with that. The key thing with this insect pest and where it's created the greatest economic impact is with vineyards. They love grapes. Not the fruit themselves, but just feeding on the leaves and the stems. And they will they will kill cultivated grapes in vineyards. And so vineyards will have to treat them. Now, they're not going to be able to continue to use one of their primary materials, which is a neonicotinoid, which is dinotefron, which is quite effective lanternfly. They're not going to be impacted by this restricted use of neonicotinoids. Their choice is usually sulfur, the active ingredient. So they'll be able to continue. And they use other materials like and pyrethroids as well for the grapes. I have a question mark. It was an early slide. I wasn't sure because some false reports had been made. They do not, lanternflies will not feed on conifers. However, some Christmas tree growers I monitor and work with will lay eggs on Christmas trees. And then if it's a choose and cut operation, if you don't notice them, they make some eggs on the trunk of the trees. They bring it inside. They cut the tree down. They bring it inside with warmer temperatures. Suddenly, you got just like praying mantids, the same thing. You can have these spotted lanternflies climbing up your walls. So, same thing happens with mantids. Those of you who make and so anyway. All right. So I think because of the slide clarity, it's going to be difficult for me to even show you this, but this is the leaf, compound leaf, pinnately compound leaf. And one way you can tell if it's a tree of heaven and not a black walnut or one of the sumac species, because they do have similar looking, pinnately compound leaves, is that if you look at the base of the leaflets, now these are individual leaflets. This is one leaf right here. We have individual leaflets that are pinnately compound, opposite or sub-opposite. They're slightly off. You look at the base, you'll see these, what they're called glandular teeth. Usually they're in either one or two of them. Sometimes there's one on one side of the leaf and there's two on the other. And so, for example, right here, you have two glandular teeth and then one on that side of this one particular leaflet. And the leaves themselves, the leaflets themselves are smooth edge. Okay, whereas something like a black walnut, see, I got to confuse myself there. Black walnut, no, it's sumacs, unless it's a smooth sumac. Sumacs will have a tooth or serrated teeth at the edges of their leaf margins. So anyway, the thing, try to make sure you look at is look for these glands at the base of the limbs of tree, and then you could be pretty self-assured that that's what you have, as opposed to black walnut or one of the sumacs. That's a better one. You see that nice clear photograph. Sometimes two, sometimes one of these glandular teeth there. Okay. And there's some of the controls. Good question in the back is what's available. And the neonicotinoids are going to be no longer available for homeowners in the future, or even on their landscapes that can't be used anymore. Pyrethroids can, and you got some of these malathion and 7, these carbamates, and soaps and oils can work, but you have to have direct contact. And if you have a big tree, and say it's a 50-foot tree, you're going to have problems. You can't apply them. We won't be affected by that. So that's what systemics like the neonicotinoids, because they would last almost all season long, a couple of months, 3 months or so. We've lost that material now.
I have a question. Do they come down eventually? Or they run their own time?
Yeah, they often will come back and forth. And as I indicated, when they are ready to lay eggs, which is starting as early as, late September, when they start laying eggs, and they'll lay eggs through October and even into November. Usually by the end of November, they've laid their eggs. You might have a few that may attempt to lay eggs in December, but for the most part, it's going to be primarily October is the big egg laying month. And they will lay most of the eggs. If it's a big tree, I have a red maple on my property, and I don't know how tall is it. It's maybe at least 50 feet tall. It's a big tree, and it hasn't been infested yet, but I know for fairly certain that next year, because the last 2 years we've had a slightly increasing levels. This year it's going to be the 3rd year, and I think they're going to reach a pretty high population, and so that tree is going to become infested, and I'll probably just let it go. The important thing that needs to be known, other than things like vineyards, which is a problem because it will kill those grapevines, is that these spotted lanternflies are not going to kill your trees. They're a nuisance, because of the honeydew and the black sooty mold. And they could get so severe that you could walk underneath a large canopy of a tree. It's raining honeydew, and how severe it can get. And then anything underneath it will get coated with the honeydew, and then that black sooty mold will grow on the honeydew, and then it becomes black under there. And I don't have pictures of this, but there was an tree of heaven, which was always a very weeded area, not too far from where I live. And it killed all the weeds that was underneath the trees, because maybe it's a side benefit to it. So it's just all black though. It was just quite a sight. So that's a nuisance. And there's I mentioned neem oil. This Bovaria bassiana is a botanical. Again, the label says you may have to spray 3, 4, 5 times to get satisfactory results. So, these biorational types, reduced risk types, are wonderful. And we want to try to use more and more of them when they can work. But they're not going to, like I mentioned before, if you have a problem with an insect, it's going to, especially if it's going to kill your tree, we want to kill the insect pest now. We want to, like I said, make them hit the ground screaming. And so these reduced risk materials usually don't do that. It takes time. And so anyway. The predators are being worked on. Almost many of the land-grant universities, especially in those states where they have the stations now, they are trying to determine if some of what they're called pyrethroids, which are wasps, which are found in Asia, We have pyrethroids here, but they're usually very host specific. They will only feed on a certain number of insects that they prefer. And so what they have attempted to do is bring some of those pyrethroid wasps over from Asia and introduce them here in the United States, but they have to be really careful when they do that. They're not released yet, but they're being studied. And this is something that takes usually a good decade to make that determination. Is it going to cause some undesirable side effect? Maybe these wasps are going to start attacking things we don't want them to. So that has to be determined, and it takes time before we can start doing mass releases of what's called classical biological control, where we go where this exotic pest came from, find the beneficial predators and parasitoids, or in some cases pathogens that were keeping them suppressed and at least satisfactorily controlled over there, releasing them here where they're not present, and see if it will be successful. But we've done that successfully in some situations. Those of you, I know many of you here are old enough about the gypsy moths that have been, which is now spongy moths, that made a name change last year. So the gypsy moth, it's the spongy moth. Gypsy is considered to be an ethnic slur, so they made the change. Yeah, I wasn't even aware of that, but spongy moth is a new, technically correct. The scientific name hasn't changed, but the common name has, and so it's called spongy moth.
Yeah, that was introduced
Country. Just after the Civil War, like almost around 1870, up in the Massachusetts area, and then it took decades for it to spread throughout much of at least the northeastern sections of the country, and it's still spreading west 100 years later and 150 years later. And so, but we've done a good job of keeping that one suppressed by going over to an area where there's the Asian gypsy moth. Even though we got I keep saying gypsy moth or spongy moth, we initially got that from Europe. That was introduced. Now there's an Asian gypsy moth where they have this fungus that's called Entomophaga maiga. It's in the soil. Yeah, I like to say that because I can. But they brought that over. They attempted it around the 1910s or 15s, something like that. It didn't take, so they attempted it again in the 1980s. This is the United States Department of Agriculture was doing this, and they released it in Massachusetts and New York and Virginia, this fungus, and it took off. It likes cool weather and wet weather, which is ideal for the springtime usually, and at least in the Northeast. And that's when the spongy moths are becoming active, and they're hatching. You start hatching in late April, and they feed in May and June. But this fungus can decimate the spongy moth caterpillar. And so, and there's really been no real serious side effect with that fungus. They call it Entomophaga. And so that was a success story. But they had to be careful with doing that kind of thing. So we can't just randomly start trying, see if it works or not. No, they have to keep it contained and research it in a contained area before they can release it. So yes.
Are there things that are making them confident that the lanternfly does not kill most trees that it?
Yeah, well, it's been shown, it's not that it doesn't kill plants. It's been shown to kill small tree of heaven. It's not a bad thing, because tree of heaven, if you're familiar with it, is considered to be a nuisance tree. And that, by the way, guess where that came from? Yes. Someone said, we ought to send more stuff over there to here. And so, yeah, that was introduced purposely in the 1780s, I think it was, or 1770s in Philadelphia area, this tree of heaven, because it's a tough tree. It grows in real harsh environments. And it can, in fact, if you ever travel on like an Amtrak train, the corridor just lined with trees of heaven here in the Northeast. because that's a harsh growing condition along the train tracks. And so, yeah, it's a nuisance tree though, and it grows very fast. And yeah, yeah, yeah. It's not something you'll find typically people planting, but it's just, it just got wild. It just became extremely invasive. They also released it in Baltimore about the 1850s, I think it was. And they even released, they planted this tree of heaven in California too. And that was also about 100 years ago. So these are bad things that we did, not realizing how this was going to become a problem, 150, 200 years later. So, yeah, yes. Yeah, yeah. Of course, this all originated in Berks County, Pennsylvania. So some of the leading researchers to try to help suppress this pest and prevent it from spreading was by the Penn State foresters. And they did something that they thought would be a good idea, and I think it still might be, although I don't think the New Jersey Department of Agriculture really promotes it. But you've maybe heard of these trap trees that they decide that, okay, determine which is the male and which is the female. Make sure you get rid of all the female tree of heaven. Get rid of them. Leave just maybe 10%. If you have a lot of tree of heaven in your area, this is what they're talking about. Maybe relieve a couple of the males, and then treat those with an insecticide like Dinotefron, which is now not available anymore. And then that would be a trap tree, because they would then gravitate toward the tree of heaven that are there, and they will be killed. And the idea was that if you remove all the tree of heaven, then they will just go to another species, like black walnut or red maple or a birch or something like that. And so this way we could use that desire to go to tree of heaven and use it as a trap tree. And it did work. In fact, I have some nurseries that are doing that, and they're purposely putting containers of tree of heaven around the perimeter of the border of their nurseries. And they're treating them with Dinotefron, this safari, this systemic, that lasts about 2-3 months. And so that's about all they need to do once a year to go after the adults. So they're targeting the adult stages. And the 3 nurseries that I've worked with that have done this, these border perimeter trap trees, which is funny because they had to purchase the tree of heaven. And there's the supplies now that became available where you could purchase tree of heaven in containers for nursery growers who want to do this. And some of the nurseries that I worked with, the number of spotted lanternfly that were killed, these border trees, tens and tens of thousands, just amazing. And the idea is not to prevent them to the nursery where their crops are, and not to feed on the trees that they're going to be selling and growing. So it's kind of like a perimeter defensive protection zone, and it seems to have some value to it. And I've had a number of nurseries that have attempted. The thing is, I don't know the numbers as far as how close these trees should be around the perimeter, but some of them have made different attempts, and they all seem to have some value. So anyway, okay, so these are some of the non-chemical controls, like the sticky banding, sticky traps, the circle traps. And if you're going to remove the tree of heaven, this is something that is kind of important to know. Have a tree of heaven, as kind of relates to your question. Took me a while to get to it, didn't it? That's the trouble as I get older. I get sidetracked. The tree of heaven, if you're going to remove property, which is probably not a bad idea, because you're going to have less on your property then of these spotted lanternflies, is that you don't want to just simply cut it down, because this particular species has such extensive roots suckering, not only from the stump of the tree, but well beyond from the roots. In fact, if you have a big tree of heaven, you could have roots that extend 50 feet in all directions. So if you just simply cut them down, you can stimulate this root suckering. And I told my niece to not just simply cut it down, Is she gonna listen to her uncle? No. She just had someone come over and cut it down. They didn't apply an herbicide first. So what you want to do is you don't want to cut the tree first and then apply an herbicide to the trunk stump. Some tree species works, but not with tree of heaven. You've got to treat the tree first before you cut it. Wait 30 days. And one material that works well is, well, glyphosate works well, which is Roundup, which is available to homeowners. Triclopyr, you have to have a pesticide license to apply that. So these are both herbicides, systemic. Triclopyr is really effective as a systemic. You just simply treat the trunk of the tree, not very high up, maybe about 18 inches up and around the circumference of it down to the roots. They wait 30 days because it takes that amount of time for the herbicide to move down through the roots, and it kills all the roots. If you just simply cut it down without the herbicide, the tree responds with all these roots suckering, and it's too late. So if you're going to cut your tree of heaven down, you really want to have an herbicide put first, then wait at least 30 days, and then you can cut it down. To wait longer than 30 days, maybe even better. No, wait 60 days. But you don't also want to do this when the tree is actively, with leaves still on the trees. You don't do it in fall. This won't work as well. So do it sometime maybe August and September would probably be the two best months. By the time the tree starts to go into dormancy, mid-October, it's too late. You've missed that window. So that August, September would be a good time to apply the herbicides. Some of you have these tree of heaven in your yard and you like to get rid of them? That's just kind of an important thing to remember to do. So neighbors, okay. Yeah, sure. I don't know, bamboo is really bad. That's really invasive. Probably not that bad, but it's, yeah. I know, it's endless. Yeah. Okay, all right. So we finally finished with spotted lanternfly. Wow. So we got 30 minutes to break. All right, we have these piercing, sucking mouthpart insects, and they would include things like aphids and lace bugs and mites, spider mites. Scales, we have primarily groups of scales. There are scales and scales. They feed in different parts of the plant. The soft scales will feed on the sap, and they can produce honeydew. Armored scales feed on cells, and they cause discoloration and dieback. And I'll talk about the scale types. Then we have these walk balls. I'm going to get that. Before I get there, we do have these chewing mouth parts, and the groups will be caterpillars and sawflies, which are actually wasps, larvae wasps. And then we have root weevils, and then wood borers. Wood borers, many of these insect pests in the urban landscape are cosmetic. Aesthetically, they make your plants look what you don't want them to look like. You're not going to reach its full potential. But to tell you, the wood borers, they're the true assassins of the landscape. They kill trees, whereas many of these other insects I will talk about are just causing aesthetic or damage to them. Makes them look bad, but not necessarily kill them. And what will often happen is that these other insects, like for example, the spongy moth, doesn't directly kill. I mean, their favorite tree are going to be the oak trees. It usually doesn't directly kill the oak trees, but the spongy moths with their feeding weakens the tree, which calls in the wood borer, two-line chestnut borers. And then they come in responding to that because they know that the tree is weakened, and they're going to be able to successfully invade it and feed within, the vascular tissue and destroy it. All right. So I do have a couple of galls, and these are both on oak. Oak gall. There are many of you, if you have a pin oak in your yard, good chance that you've had some of these galls present. They grow on the branches, and sometimes they can get numerous branches. Okay. The difficult thing to control, and this showing you all the exit holes of wasps exited. The adult wasps came out of where it's feeding. And it's a kind of complicated life cycle. It takes 2 years for for it to go through its life cycle stages. And the first year it feeds on the leaves, and then it moves into the stems. And for that first year in the stems, it makes kind of a small gall, not particularly noticeable. And then the second year, is much larger galls. And then that's when they complete their life cycle. Some of them might even take an additional year, and they'll emerge as adult wasps, and you see these holes within the gall. But they can kill branches. So galls are really curiosities that are not going to live in damage. So 2 exceptions, and that's the horned oak gall. That one, yeah, like a medieval mace weapon is shown there, and each one of those spikes is where adult emerged. And so these galls, which are pretty, is maybe the size of a golf ball, they can contain a lot of insects inside of them. Okay. All right. But I didn't really want to talk too much about those, just to make sure that you realize that this is one of the few galls that can be serious. And I have a pin oak in my yard. Have these galls? I do, yeah. And guess where I got both of these photographs? From my pin oak, yeah. But it's been growing for years, and it's never gotten to be too severe, because there are some predators that will keep them in check to a degree. But eventually they might overwhelm the predators, and they become so severe that they start really killing a lot of the branch. Yeah, the controls are these are difficult. The window of opportunities are quite narrow. Probably the best window, because the systemics don't work. And so you have to do contact sprays when they emerge from the leaves during that first year, when they finish up, and the adults will move to the stems, and they'll lay eggs within the stems. So it's that period of time when they're trying to lay eggs into the stem, that's your control window. And you don't really see these guys, but there are, periods of times when you can have a pretty good idea of when these adult wasps are going to be active. And so you can control them at that time. But it's a really difficult timing thing to do. Most professional landscapers throw up their hands, and we can't control these. And so it's a difficult thing to do. Yeah, it's one of those, I know systemics keep trying to be used. Systemics, if you don't know what that term means, it's usually when the vascular tissue, vascular vessels of the tree, and be the xylem in this case, where the water is being taken up from the roots up into the canopy of the tree. This is where the chemical will move up xylem into the entire canopy of the tree. So, oftentimes that can be really successful to be done. Spotted lanternfly, that's why the systemics work well, because it moves up where they're up higher on the trees, and you can control them. But apparently the systemics don't work. It's one of those things that you almost have to live with. You can prune them out, but if you have so many of them, you might end up pruning half your tree. And so anyway, it's not an easy one. So let's get to some other ones. Like this is the junior varsity test, and the land aphids. That's the one you often see early in the spring. And aphids are not considered to be a serious pest. They get a lot more attention than they deserve. They feed on the young, growing, soft, succulent tissues, and they cause distortion and curling, and they become noticeable during the spring month. But are they going to do much damage to the trees? No, they won't. And then another thing that if you allow them to, the predators and the parasitoids, these beneficials, will come in, and if you're a little bit patient, come in, they'll take them out. Unless you're applying chemicals all the time and you're killing off all the beneficials, then you'll be forced to try to kill with chemicals. And we try not to get into that pesticide treadmill approach. And so, yeah, the roses is maybe one exception where you want to protect your roses against aphids. If you're a nursery grower or greenhouse growers, you don't ignore aphids. You got to control them, because you got to sell those plants. You can't sell them infested with aphids. And so that's one that you you have to control. But in the landscape, you're not selling your plants, and as you allow the beneficials to come in, it may take a couple, 2-3 weeks, but they eventually come and will take them out. And the damage they do is usually insignificant. Roses is maybe an exception. Yeah. And there's heavy infestation of aphids. And by the way, these two terms that are often used when you make diagnostic types of characteristics to describe things. Symptoms is what the plant is displaying that looks abnormal. And so in this case, distortion or curling caused by the feeding of the aphids. Whereas if it's spider mites or lace bugs, it's going to be stippling because they feed cells and they cause discoloration in the leaves. And that would be called stippling, which is a type of symptom is also. Symptoms are from a distance. You kind of move up toward a plant, you see it doesn't look normal, it looks colored, it's not growing properly, it's stunted. That would be the symptom. And then if you find the active or causal agent, that would be the sign. Okay, so that's the difference between those two terms. Another way you can look at it, many of you are familiar with girdling roots. And Norway spruce, not Norway spruce, but Norway maple is one that's notorious. Maybe planted too deep when it was initially put in, but they also have a tendency to have a girdling roots. They don't tolerate low oxygen levels. The roots kind of rise up higher and they start maybe growing around the trunks of the trees. And then when that happens, it presses up against the stem, the roots does, and can cause branch dieback. So in that case, the branch dieback, looking kind of from a distance, the crown canopy of the tree, that would be the symptom. Then you move more closely, you see the girdling root. That's the causal agent, that's the sign. That's a big deal, right? Symptoms versus signs. But you know, the diagnostic process is complicated enough to begin with. We don't need to be confused using the proper terminology. So that's just my take on it. Okay. And there's more signs. It doesn't have to be an active insect. It could be a byproduct of that insect. Aphids, like all insects, molt and they shed their exoskeletons. As they go from one instar stage to the next, they get too big, their exoskeleton, and so they grow a new one, which causes the older one that's smaller to split open, and then the insect just simply begins, and they drop that to the whatever is present, maybe down to the next adjacent leaves, and that's always going to be white in color. So you know, when you see something that looks like white specks on plants or on stems or something, what is this white stuff? It's probably one of two things. Oftentimes, it's either the exoskeleton cast skins from insects or spider mites, because they have to molt as well, or eggshells. Eggshells will always be white also. It could be different colored eggs, a red egg, a yellow egg, or black egg. But when they hatch, those shells will always be white. So see these white specks. What is this stuff? It's one or the other, exoskeletons or eggshells. Okay. And that's the exoskeleton there of an aphid. There's nothing inside, it's empty. Split open and the aphid walks out with its new, bigger exoskeleton that it grew. Okay. And there's a line drawing of an aphid feeding in the cell. This is the palisade cell. This is a cross section of a leaf shown here. And that's the top of the leaf, bottom of the leaf. And the vascular tissue, which is the phloem and the xylem, it's where the water and the photosynthetes occur. And I know you, don't I? Maybe I'm mistaking you for somebody else. Have we met before? I don't think so. You look something very similar to someone I know. So sorry. I keep looking at you. I think I know her. But anyway, the aphids are feeding, and they're feeding on the phloem. Xylem doesn't contain a lot of nutrients. Xylem is mostly composed of water, whereas the phloem contains the photosynthetes, the sugars primarily, the carbohydrates, and some protein. But like the honeydew and like the spotted lanternfly, the aphids have to suck up a lot of the phloem, the sap, and they get rid of the excess dew, what's called honeydew, what they don't need. And then that's the shiny, sticky stuff where the sooty molds start to grow on. So,
And that's an example of the, with the black city mold going on.
you can see when that gets really thick, it blocks sunlight and the leaves start to no longer being able to produce food. And it can kill the leaves and branches and small trees. It can kill small trees. But there's lots of predators out there. That's why I often refer to aphids as a varsity pest, because there's just simply so many predators that can take them out. And example of a lady beetle, we call them lady bugs, but they're not bugs because lady beetles have chewing mouth parts. So it's not entomologically correct to say bugs, but we all do it. And but they're beetle, right? And that's the adult. That happens to be I think it looks a lot like magnolia scale. They're very similar in appearance. But what it's trying to do is get underneath the scale, because this is attached to the bark of that stem, trying to get underneath of it so they can where the scale is most delicious for the lady beetle. And that's an immature stage of a lady beetle. Maybe you've seen this less often. That's a lady beetle or ladybug immature stage. It's a fairly late instar stage. And so it's going to be going through a pupation stage and become the adult. Really quite gracious, and they aphids, it's different numbers. I've heard ratios of 50 to 1. If you have one lady beetle, they can successfully suppress 50 aphids. I've even heard larger ratios than that, but they are pretty voracious. And oftentimes the larva stage of a predator is more voracious than the adult stage. And the lady beetle adult is pretty voracious, but I think probably the larval stage might be even somewhat more. Okay, and so, and there's the 4 stage ladybird beetle. You've got the eggs there are kind of yellow and on a like bowling pins, or maybe a dozen of them stacked together and kind of on end. And then they hatch, and guess what we have here? Those are the eggs where they hatched out of. And then you got the first instar, which has not looked like that other one I showed you, but it's black and then they go through. I think it's 3 or maybe 4 star stages, and they get which is a more late mature, immature, or rather instar. And then they pate, as the patient age here, shown in the corner, and then they become adults, making more of their own kind, you know, so that's the life cycle. And they live long too. They live for a couple of months or so. And so 2 generations during the summer periods. And then we have these what are called the parasitoids. If I kind of introduced this one already, this term. Parasitoids are essentially parasites that kill their hosts. So parasitoids are either mostly wasps or fly species. Speaking of flies, within the order Diptera.
And they have
The ability to most often they'll feed inside of their host. Sometimes they'll feed outside, but when they lay an egg, for example, the female parasitoid wasp will lay an egg inside the aphid. That egg will then hatch. It's inside the body of the aphid, and it starts to feed on the less vital organs first because they want to grow and develop as young immature wasps. So they want that protection in the body of the aphid. As they more mature, then they'll start on the vital organs of the aphid and they'll kill it. And so that's how these parasitoids often work. And feed, these are bean aphids. You got some white exoskeletons there from the aphids there as shown. And then these are black bean aphids, like I indicated. And you got one, 2, 3, 4, 5 of them are. The aphids have tripled or even more their size, and they've blown up and they've become discolored like a gray coloration to them. And as that wasp feeds inside the aphid, these wasps, they release gases as they're feeding, and it starts to cause the exoskeleton of the aphid to swell up. It swells them up, it discolors them, and it kills them, you know. And so all these brown ones are dead aphids, and many ones that are black probably have parasitoid wasps feeding them already, but they haven't developed to enough where you notice that often we'll call them aphid mummies as they blow up in appearance. It's pretty gruesome stuff. Yeah, well, what they're doing, there's a couple types of wasps, a few different types of wasps. I think 2 of them are egg parasites. Stage will have these wasps inject the egg inside, and it feeds within the egg contents, makes the eggs not viable. Another one is goes after an immature stage. I don't think there's any parasitoids that are going after the adults that I'm aware of. So it's the stages, the nymphs, and usually it's the first instar nymphs that they'll go after. You know, as these insects get bigger, I mean, these beneficials have to go after and try to get control of the pests, and as the pests get bigger, they're more difficult to deal with, and so they often will try to go after the very young ones because they can more successfully. Like that's what predators do, right? They're opportunities to go after what's most vulnerable, and so they'll probably leave the adults alone, but they're just going to be going after the eggs in the young immature stages. Well, some species are beneficials. I mean, we're familiar with things like yellow jackets and and some of our wasps can be pretty vicious, and you don't want to just play with them. Actually, yellow jackets are beneficial. They're native, and they go after caterpillars in the spring, or native caterpillars. But then they become a real serious nuisance in the summer period. They have a dietary change. The yellow jackets will no longer crave meat and protein. They want energy. They want sugar. And so they go after our sodas or our potato salads and carbohydrates. And they just change their dietary preference. They become a nuisance. And yellow jackets, you know, they can be pretty aggressive. So, you know, yeah, so they have benefits to them, but the consequence. Yeah, but yeah, there's so many species. You can talk days and days about them, different ones. So, all right, just a close up of these aphid mummy. And so, just the story of these parasitoids is once the wasps are inside and they've grown, and actually they have pupated inside the exoskeleton. But they're inside the exoskeleton, and they got to get themselves out. And the exoskeleton is shown here, so the adult wasps can exit, eating, going after other insects that they can feed on. So that's here. And what are these things? These white things here? What do you think? Those are the aphid exoskeletons. Okay. The ones that pupate. All right. That's just a real one there too. Yeah. All right. And look at this guy here. Wow, another predator. This is sometimes referred to as the psychopath of the insect world. The psychopath, yeah, they kill for sport. Kill, and they don't need to eat anything more. These are called green lacewing, and these are the larval immature stage. The adult stage is a beautiful insect, and it's not a very vicious predator, but the larval stage sure is. It is. Look at that. Look at the mouth parts. The green lacewing. They're pretty sharp, and they open up, and then they can go after a soft-bodied pest like an aphid or lace bugs, good thing, another pest they go after quite readily. And they can impale themselves inside the body. They release enzymes that makes the ability to, you know, the blood becomes, insect blood and contents becomes really available and liquefies them, so they can suck them out. And you can watch these green lacewings go after an aphid and impale them and inject their enzymes and just suck the fluids out of the aphid, suck them dry within a couple minutes. You can watch them deflate. And so, yeah, so it's a lot of gruesome stuff out there. Really something, I've seen it, so I've watched it. And so there's lots of insecticides. Often you can allow the predator to do their job, and they will often do a nice job with them if we don't kill them all with broad spectrum insecticides. So that's been the trend. You know, I also promote the IPM philosophy when I work with my greenhouse nursery growers. Most of them accept that. They don't want to apply chemicals where they don't need them and unnecessarily. But that was the trend when I first started in the green industry in the early 1980s. That was the by applicators and landscapers and turf managers. They were get cover sprayed by the calendar. They didn't monitor for the most part. They just applied chemicals. It was better living through chemistry back then, especially in the 70s. That started changing in the 80s and the 90s. Realizing the negative side effects that indiscriminate use of insecticides does.
Creates
Oftentimes, the predators
and the spray, they often come
develop dynamic equilibrium in a landscape, especially if it's a complex landscape with lots of different plants, flowers, as pollen and nectar, because many of our beneficials want pollen and nectar that before they can start laying eggs, but then they also are good predators or parasitoids. And so, but when we destroy that equilibrium established that's below a satisfactory threshold, we keep, as we're knocking out all the beneficials and not applying pesticides, the pests can go up, then you have a resurgence, and then you have to spray again, you know, so you have this treadmill that takes place. And so that was kind of the mode of operation for a lot of commercial landscape industries back in the 80s. Yeah, we want them to be dependent upon our chemicals. Gives us business. I had, when I was a youngster and I first got out of college and I worked for this as an arborist, I remember some of the field managers saying, yeah, we want that. It increases business. What's this IPM? We can't accept that. And so they didn't accept the IPM approach. Now I'll be talking about IPM, I think, next week. I'm talking about 2 weeks from now, I'm talking about turf. And then 2 weeks after that, I'll talk about IPM, which is sometimes this is how it worked out this time. So, all right. So these are some of the insecticides they avail. Oops, pretty reduced risk materials. They don't have a major impact on beneficials. Neem oil has less impact on beneficials, but most of the others do. Merits, imidacloprid is the neonicotinoids being eliminated for the residential landscape. And then the pyrethroids, they're probably the #1 insecticide in use today, at least in residential areas. And they work. They're using an analogy, they're like carpet bombing, military analogy. Pyrethroids just kill everything, just knocks everything out. They're inexpensive. They last about 3 weeks after you spray them, have a long residual. And so you can understand why people want to use it, because it gives them what they want. It works. It's a bug killer, but it has consequences to it. So there's a bunch of they're available for homeowners. You can buy pyrethroids. All right, so it's kind of at the top here. Symptoms. In this case, Pieris, which is an Andromeda, and you have white speckling. It's a stippling. In this case, it's from lace bugs, I'm going to break in just a few minutes, but it's kind of a core stippling because where a lace boat put a mouth part and within a skull and build the cell. And it contains the cells that it's feeding in are just right below the upper surface of the leaf. And it's where photosynthetases are being developed, has chloroplasts, and so that green color is removed, the chlor removed, and it causes that discoloration to take place. The cells are killed, and now become white. And so it's really getting in here now, but you got some immatures that are present, and all of this black stuff. I don't know if some of you, you're not familiar with lace bugs, but they're really common in plants like rhododendrons and azaleas and things like hopper, asters. They cause the stippling to take place. Okay. And you can't see it now. This is really getting kind of bad for observing, but they're showing the chlorotic stippling of an azalea. Just to finish up, we'll take a break. I'll tell you a quick story. Is that I was working for a company. I was, as I said, I was an arborist. I was in the pest management division. I was in my 20s, and it's one of these things you just don't forget. You know, I came to a really nice home, a residential area. I think it was in the Hudson area. And I walked up to the front door, something we're always required to do before we apply any application, make sure the permission to do so. And I walked by, I was on the sidewalk, I saw the azaleas they had, nice looking mature azaleas, just loaded with this white stippling from lace bugs. I knew immediately what they were, the azalea lace bugs. They feed on the undersides of the leaves, so you don't see them. You have to lift the leaves over. Oh, look at them all right there. But they do give themselves away by that white stippling. I saw them. I walked on the door. Before I could say anything, the woman says, "Oh, by the way, I love that variegated look. How did you achieve that?" I said, "Oh, no, I didn't do that." That was from an insect. So she wasn't so excited anymore. But I had to show her what they were. She had no idea. And there they were. And so, all right, let's take a break. Yeah, I'll get to it. Yeah, I will. It's always, yeah. I do have some slides on there. Yeah, come on. Yeah. Trying to turn it off. What a
Charge your battery. Although I tell you,
Good. Oh my gosh, I'm gonna sit down.
They're all back. My son's wedding. They're not real fancy. No.
Oh, this baby, I'm getting so old, I can't open a snack pack. They're getting worse? Oh, good. I'm glad it's something. But I'm getting old too, so.
You need a tool opener.
You need heavy tools in your kitchen anymore. Yeah.
You can open with your hands. An egg cart.
Yeah.
I did these, like grapefruit section from Belmonte, and but sometimes they'll open difficulty, other times, I like, and it's thick plastic lid. I'll use all kinds of openers, I'll use screwdrivers, I'll end up hammering through the lid with a chisel, and it's awful.
You know why? Somebody, like I'll use antifreeze as an example. When a kid gets an antifreeze and gets sick or dies, they sue the manufacturer because they made it too easy to get out of the container. The manufacturer's not responsible, it's you are. You took the antifreeze in the house, I think, or garage. That's
I
why
know.
they make it so difficult to
It's
get open.
ridiculous. Kids are responsible for nothing. I was responsible for everything when I was a kid.
Yeah, tell me that.
Yeah.
And the same email the other day where it just be the teacher. And I could email people, if that had happened when I was in school, you would have been expelled immediately.
Yeah.
You would have been charged with assault, and you would have been in jail for about 6 months.
I remember like teachers like almost hitting kids for not paying attention to things.
When I was a shop teacher, had hands like this.
And now, like, I had a friend who, she was teaching like fourth grade or something. She's supposed to have 31 different teaching styles for 31 kids. Like the parents are like, oh my Johnny, you have to look at him when you're teaching. You won't get, or my so-and-so has to sit in the front row and you have to call him a lot so it feels engaged. Like,
Well, I'm 75. The teacher had total control.
mhm.
And if anything happened, it was even more control. You don't have three parents in the home. That's hard.
Yep. I know it's funny, like, when I was a kid, I had to wait my turn to be polite, stand in line and wait my turn. Now you stand in line, kids walk all over your feet, pushing in front, and you're supposed to select them in.
Have respect for anything.
Or like, yeah, there's like no respect for anybody's rights.
I did something when I was a kid, and I thought I got away with it, sit down at the dinner table. My father said, what did you say to so-and-so? He said, the next time you see me, you'll apologize. You understand? Yeah, I got it. So the next thing they asked, what? So I was thinking at the time, I thought that was the end of it. Are you serious? You can't discipline, you don't get disciplined at home, and you can't discipline them in the schools. Tolerate it. Imagine being a teacher.
Or shooting a teacher.
I went for one year, all you see was a gun's hands. This, and a pointer or a yardstick.
I had a friend who was so nearsighted he couldn't see the blackboard, but nobody knew it. And the teacher, none broke a poker over his head. The pointer broke a pointer over his head because he didn't read what was on the blackboard. His father came into school and that was the end of that school for him.
Well, you can't see it. That would be a telltale sign if the kids get really bad grades. There might be a problem. So a comprehension problem, I can't see it.
It's funny because they used to have the eye doctor come into school and test and the dentist. Then the parent would get a note that so-and-so needs to go to the dentist.
I didn't get an email or anything about this machine. They sound.
I think she might have, because I would display this work, and I'm somebody sitting here, they said you missed the email. She's pretty good. She's pretty good.
My dad was in transfer. We're talking back in the early 60s. And so I was they talk about speak English. Yeah, but the thing is, I kept that slowly talking speed. I can't get rid of it. So I So let's go on with these lace bars. You see now, I think someone did some of the lines. I didn't realize you could do that. So thank you, whoever did that. You got these symptoms of why lace bars. I had someone speak to me about how to build these. And, that's the lace bug itself. Okay, that's the Azalea lace bug. There are different species of lace bugs. And they're going to be on the undersides only, and there's some sucking mouth parts, so they're feeding, in this case, they're feeding them the cell. So they don't breathe some kind of honey, they're not feeding the sap. So the cause that stippling occurrence to take place on the leaves. In this case, it's not a lace bug because all lace bugs feed on the undersides of the leaves, and this probably is some kind of plant. Right? This could be a spider plant. This is John Davis from the University of Maryland, entomology professor. And he's showing you the lace bugs and spider mites that feed within the palisade parenchyma cells where the chloroplast will food for the plant. You see the stippling of the kill cells, the cells are killed. And plants, when a cell is killed, can the plant regenerate that tissue again at that same spot? No, they're plants. They're not animals. We can heal ourselves. Plants don't heal. All they can do is cover up and we can seal over the damaged area. So those cells will never be able to be regenerated again. So they'll always have a discoloration to them. And so these are a number of different lace bugs that you find in the landscape. And they're primarily what's known as host-specific. They like to feed on just a few selected plants. And in fact, you have an azalea lace bug and a rhododendron lace bug, and many times in our landscape, we'll have both of those plants right next to each other. But one azalea lace bug will not move over to rhododendron and vice versa because of that host-specific. And, many times these pests will go after plants where they can tolerate plant offensive chemicals. Plants try to defend themselves, so they produce toxins. But some toxins are able to be circumvented, you might say. Perhaps an insect will have enzymes, a pest that can detoxify these defensive chemicals quickly and doesn't affect them, so they can digest the food without any negative effect. But we also have these other ones like the Rhonda. Hawthorn lace bug will feed only on deciduous, more deciduous type plants, or semi-deciduous. They have different shapes to them. If it's a one that feeds on evergreen, it will be this shape, or like an oval shape, whereas if they feed on that's if they feed on evergreen. So oval shape. If they feed on deciduous plants, the species will be more rectangular shape, squared off things. So I do a lot of walking around, especially when I was working as an arborist. I walked into the landscape. I occasionally get lace bugs on the shirts and on the sleeves. I could see, they've got squared off wings that came from the deciduous plant. So I wouldn't bother looking for them on and sometimes they, for such high populations, they start initially comparing with spider mites. Usually spider mites, that's what it doesn't have smaller mouth parts. Spider mites are about 1/50 of an inch in size. Many times larger, of course, the lace bugs. Just to emphasize, I mentioned before, predator is called the lace wing. It's completely, that's a predator. Lace bugs are pests. You don't confuse that. Lace bugs are pests. Lace wings are predators. Those are the cyclops. I mean, this is kind of, you have a large white oak in the backyard that's 200 years old, it's huge, and it gets infested with opalase bugs every year. Is that gonna be a concern? Should you spray multiple tens of gallons of insecticide to protect the tree? No. The tree, it has mostly, like I said, this film before, mostly bark and no bite. So it's just cosmetic only. And you do have predators that may come in. Those bugs. And again, underneath the leaves, are always going to be underneath the leaves. And, you know, right again, though, that you can see the adults, and they are squared off, and you can't really see it, it's too bright. You have all these immatures that are more black coloration to them. You have all this speckling in place, and that is the waste of water, the cracks. A good kind of message. People don't realize about the leaks and factors going on. See that something it's hard at the top of the lead and just turn things over sometimes with people that you know. This is. In fact, actually, this is all different life stages on those things. So you've got eggs and 5 instar nymphs, and you've got adults. So you've got 7 different stages. This area right here, see that? That's all evenly spaced around. Those are eggs. Like a little tiny miniature Stonehenge. They put these eggs, a little bit elongated, not much. And they stick them. And then lace bugs do like to feed more in the sunny type of environment. We'll find the rest of it in the shade. It's not so much that they really prefer to feed plants in the sun. It's just the fact that there's less predators in the sun. In a sunny site, predators really prefer more cooler, shady locations. And I don't have a photograph showing the percentage of the lake bugs. Afternoon sun, the highest percent, as far as the high percentage is going to be in those sites. Whereas on shaded sites, it's going to be less than half that. And in fact, it's predators. It's simply, there's more predators in the shaded environment. That's what I have that photograph. You know, if I did monitoring the landscape, it's a shaded location, I probably don't spend a lot of time with the I may be having some there, but I just realized there'll be a lot more green wasting. You'll have more spiders and those types of great predators, and they'll help to keep the lace bugs under control. Whereas in a hot, dry, sunny location, the predators are less prone to be there. They don't like them. They don't favor those sites. Especially, I mentioned things like parasitoid wasps and flies to a less degree. They cannot tolerate dusty conditions on hot, dry, summer dusty conditions. They're just going to fry. So there'll be few of them there. So yeah, insect pests take advantage of those sites because they can build up to higher levels. And, right. So as far as control, oils and soaps must contact the insect. I was speaking with someone during the break. And since they feed on the underside of the leaves, oils and soaps, that can really believe because if you just spray over the top, it doesn't use it. You have to have contact. Now, oils and soaps must contact the insect directly for them to work. Oils work as kind of disrupts the respiratory process of the plant to kind of basically suffocates them, where soaps cause a desiccation because it's going to dry out. And so they both require a lot of direct contact. Now, oftentimes by PM, we prefer to reduce the amount of insecticide that we spray in the environment, but spray only where it's needed. But when it comes to oil, especially, soaps are a little more chemical. You really want to cover the area very strongly. Bats, well, bats will be feeding on things that fly, usually at night, and that's their primary pests will be moths, night flying moths. There are other things that belong to- No, bats are just an outstanding predator. We don't appreciate them. They creep me out. I see bats and especially around house, they'll start flying around. It's that herky jerky motion that they're doing that kind of freaks you out. And no, really unrelated to anything. But I was running like years and years ago, trying to get home before it got dark. And suddenly I was on this trail that was lined with woods. And I was moving as fast as I could on this bike. Suddenly I felt something hit me. I looked out, it was a bat. Yeah.
I'm scared of that.
Yeah. That has a face on the mother's blood. Okay. All right, so there's 3 generations. Here's the systemic